Hello, everyone. Thank you for joining us today for the AIAA Los Angeles Las Vegas section meeting. No, there's no microphone for in person. Microphone is for online people. We're going to start the program now. So first of all, thanks for everyone coming here today. We have a distinguished speaker and a wonderful topic, very exciting. You'll learn a lot. The other thing first, we have some logistics, and we have, for the in-person folks here, we have coffee on the back, and also snacks and bottled water. And the restroom is right outside. If you go outside the meeting room, turn right, you will see the restroom. So that's for logistics. And again, if you are a member, welcome back. And if you're not yet a member, please contact us. We want you to be part of the AIAA, a big, great family. So again, and for people online, if you have any question, please welcome to click raise hand or type something in chat, and we'll try to unmute your mic, give you the mic access, so you're welcome to speak out and interact with the speaker. Of course, you're welcome to also type in the chat, but because speaker is focusing on the presentation, so he might not be able to catch your question right away. But
you can be watching.
Yeah, we're watching.
Ken will be watching for questions.
Yes, I'll help on the side, watch for the questions. But if you click raise hand, we'll enable your mic, and you are welcome to, at the right moment, to speak out your question. Dr. Bradley is very knowledgeable. He would like to interact with you and to answer as many questions as possible. So other than that, I think this is all I can say about the logistics. Next week, we'll have X15 presentation in Long Beach, a week afterwards in Lakewood. And so please stay tuned for AIAA Los Angeles Las Vegas section activity. Thank you so much. Thank you.
All right, thank you, Ken. All right, so our topic for today is geoengineering to mitigate climate change, and what is the specific role maybe for aerospace. And I'm Dr. Marty Bradley, and I have a bio slide which I'll put up. All right, here we go. So I'm an AIAA fellow and a retired technical fellow from the Boeing company. It's been 3 years now. I have 39 years of aerospace experience. I'm now a consultant and educator focused on sustainable aviation. I do support multiple clients. Electra.aero is one of my clients, and I have a position of senior technical fellow there. Over my career, I varied quite a bit I did low observable aircraft, I did hypersonic aircraft. I did a lot of things until I kind of settled into the last 20 years or so looking at different aspects of sustainable aviation. I did a lot of work on propulsion of all kinds, contracts for NASA, and before I got more and more into the environmental impact of aviation. I am an adjunct professor of practice at the University of Southern California. That means I'm a part-time professor, and I teach their aircraft design class. I have all of my degrees are from the University of Southern California. I teach the aircraft design capstone course for the seniors. I also teach AIAA short courses, design of electrified propulsion aircraft, and another short course on sustainable aviation. And I do also some STEM education and outreach kinds of activities. One thing I do not want to do today is I do not want to debate climate change with people here. I think it's less of an issue, less contentious of an issue now than maybe what it has been in the past. Everything we're going to do here today assumes we have a problem with the climate and the temperature is rising. What can we do to reduce it? I guess if you don't believe that that's really happening, then you don't need to worry about anything else I'm going to say today because it's irrelevant. So anyway, I'm going to avoid that discussion if at all possible, although we'll see what the interactions might be. This just shows, right, temperature rising, CO2 going up, sun cycles as well are shown here. So, you know, in my opinion, things are definitely going on. Temperature trends are up, and this whole presentation is about what can we do? Do we have any options relating to controlling that temperature rise? So the agenda for today, I'm actually going to give a little bit of the intro to this is kind of the way I wrap up my sustainable aviation short course. I wrap it up and I mention geoengineering, so I'm going to repeat that for you today. Then I'm going to talk about a little bit of history with the AIAA and geoengineering. We had a panel in 2017. I'm going to talk about that. And then in the news, what has changed since 2017? I'll cover some things the way I think that things are changing. And then there was an important workshop held by the National Academies about climate intervention in an Earth System Science Framework, which is actually conducted in June of this year. And so the topic's becoming more mainstream. And so I'm going to draw from some of those presentations. And we'll have a Q&A and discussion where we go from here. One of the purposes of doing this is to figure out, is there maybe interest in doing a more elaborate event, invite more speakers in on this topic, kind of thing. So, is there some more programming that the AIAA local section or the AIAA in general should be doing on topics like this? So here's my sustainable aviation course. I finished teaching it live back in May and June of this year. It's available online. If you want to take a look at it, you will have to pay for it though. It's an hour on demand AIAA recorded course. Talk about all aspects of sustainable aviation, which is kind of what the other side of the problem we're going to talk about today, right? And those are the emissions coming from the airplanes and other sources, and what are the alternative fuels and energy sources that can be used for that. And we talk about the aircraft design implications of that and those kinds of things. So if you want to learn about sustainable aviation, that's a good place to go. So say that. Okay, now in that course, we go through these topics. You can kind of look at them quickly here. We cover emissions, we cover contrails, CO2 and non-CO2 emissions and their impact on climate, fuels, and electric aircraft. And I do a wrap up and I compare the pros and cons of some of the different things. Okay. The way I wrap up that course, I'm going to use as the intro to the lecture today. So I show this cartoon from The Economist, where the firefighters of the climate change rapid response team are riding a snail trying to chase down a fuse toward a hotter Earth that would be difficult, right? So are we doing enough, and are we doing it fast enough? We probably aren't doing enough. We're probably not doing it fast enough. So this kind of highlights that. So I overuse this cartoon a little bit. Okay, and then I tell my students in the sustainable aviation class, if none of those reduction mechanisms for aviation and other forms of transportation work, well, maybe aerospace has another chance to save humanity by using geoengineering. And so I just introduced the idea of blocking some of the solar energy using some kind of in-space reflectors. And then another one that seems to be very aerospace related, reflect the solar energy from the stratosphere back up. And we'll be talking about both of those topics in more detail today. There are other measures, like the things that you can do in the oceans and on the surface of the ocean, and sequestering carbon and cloud seeding at low altitudes, and some of these things, which I'm not really going to talk about much today. They're not as aerospace focused as some of the other. And then I show the idea of using a high altitude aircraft to dispense aerosol particles in order to do some of that reflection. And I reference people to this paper that was done in 2020 on one of the aircraft designs that might be able to do that. And then really kind of for fun, I throw in one more thing. If none of that works, then aerospace can still save humanity by taking some of you to another planet. I spent many, many hours playing different games, including Civilization and Alpha Centauri and some of these other games. And one of the ways you win Civilization in some of the versions is to be able to build the colony ship to leave the planet, and then you win the game. So that's another possibility. Some people have talked about that, including I guess Elon Musk has talked about that. But anyway, aerospace may be the answer to a terrible question. Okay. My final thoughts to my sustainable aviation colleagues and students is the planet is worth saving, and so is aviation because of the benefits that aviation provides to society. And the little asterisk, if you follow the little asterisk, it goes down to actually the planet will be just fine. They don't really care about humans. The planet doesn't care that much about humans. So some version of the Earth will continue, even if we make it too hot for humans to survive easily. And yes, the intelligent cockroaches might take over, ruling a much warmer Earth. In our the sustainable aviation class, they talk about zero emissions all the time, and that's actually pretty impossible to get all the way to zero emissions. So we define that terminology. We talk about many aviation and non-aviation technologies, like in the energy sector, working together can reduce the overall environmental impact of aviation. A couple of the ideas like battery electric aircraft and hydrogen may have no direct CO2 emissions, but they still have indirect CO2 emissions that contribute to climate. I do mention in the class that aerospace may be called upon to help with geoengineering to fight climate change, hence the topic we're going to talk about today. And let's see, I've given some ideas. People that are taking the class are the ones that are going to be working on them, and we really don't know how well it's going to turn out. It's exciting and a little bit scary at the same time. Yes, sir. Yeah, so that'd be the emissions in the manufacture and transportation of hydrogen. Yeah, right. That's what I mean. Direct is whatever the airplane is consuming and emitting, and everything else. In the course, we emphasize the entire life cycle impact from production to use. If you have something quick that helps clarify, yeah. Well, I mean, we'll have full Q&A at the end, but certainly the thing is that the audience online may not be able to hear you. I can repeat the question. I don't know. Multiple people. How many people online, Ken? Yeah. Okay, so if you have a question, I'll repeat that question.
No, I was just in concept. You could have no indirect. In concept, in the future, you could have hydroelectric or hydrogen, ammonia, related.
Exactly, right. That's when I talk about the concept of a control volume around the airplane, which aerospace controls, and a control volume around the production of the energy that it uses, and that's the energy sector. And yes, as the electrical grid gets greener, we have more sustainable energy or near zero emission energy. Yeah, a lot of things improve. Okay. All right. So what I thought, I organized a panel at the AIAA conference called SciTech. That's the January conference on solar geoengineering in January of 2017. And I managed to get together some experts, and there were people looking at this all the way back then. I was kind of inspired to put the panel together because I had run into a person from the EPA in the government. He was about ready to retire. He said people in the government were starting to be interested in doing this, although none of them were really saying it yet. So I thought that was kind of interesting. But we had this panel at SciTech in 2017, and you'll see various forms of this chart: climate impact versus time. If we do nothing, we're on the red line. If we cut emissions aggressively, we might be able to bend it over into this black line. Maybe we have the technology to remove CO2. And solar geoengineering was shown as a possibility to how do we take the peak off of this curve, right? Because the climate impacts get worse and worse as we climb on the y-axis. So we had several people, including we had a lawyer, we had a climate scientist, we had several people, and I'll talk to you a little bit about that. It came from the idea in 2015. There was a panel called at one of the other AIAA conferences called Climate Change and National Security. And that was the first time I'd seen any content at AIAA relating to climate change. And the theme of that panel was climate change will cause disruptions to countries and people around the world, which will create stresses which could very well have national security implications, right? You have refugees, you have desperate countries. So those kinds of things were, what was talked about there. Very popular panel, lots of people, standing room only. Everybody was starting to get concerned about climate change. They just barely mentioned geoengineering. It was mentioned as a dangerous option due to complexity and uncertainty. They talked about the iron law of unintended consequences. You're going to mess with something. Is it going to have the impact you intended? Maybe not. But they didn't talk much about it at all. Right. So I thought, okay, why don't we do a panel to talk about those things? Because I'm not scared of complexity or uncertainty. And it's a good thing that we should be talking about this. Okay, so our panel was, what are the possible ways to reduce climate change? And the emphasis was on aerospace applications of different kinds. Okay, so kind of the background, the introduction to that panel was, what is geoengineering? It's using technology to counter the effects of climate change. It's controversial, acknowledging that it's a controversial topic. The kinds of things you hear about geoengineering is some people think it's counterproductive as it diverts attention and resources away from reducing greenhouse gas emissions directly. Others feel essentially, right, that if you tell somebody you have a solution to their emission of CO2 and greenhouse gases, they're not going to bother to reduce their greenhouse gases because say, oh, well, you can fix that for me. So there's concerns like that. But others think that this may be one of the few ways that you actually could mitigate and reduce the impact of climate change, especially if you wait too long and it gets temperatures get too high too fast. So there's a few more things that we'll discuss in more detail. My idea is we should be studying this. We should be using the possibility of using high altitude systems for observation and satellites as well, but also high altitude aircraft for sampling. We should be studying whether we can alter the atmospheric chemistry in a way that may be beneficial. What about the idea of deploying reflectors or scattering objects in space? And then look at other possible solutions for geoengineering applications. So that's kind of how we set up the panel. We ended up with these 3 people that were able to come and give us a presentation. A little bit of a dig on the venue we were at. It turns out that SciTech was in Texas, right? So I was trying to get local people to be on the panel, and I had a very hard time finding people. In Texas, right, especially at that time, a lot of people were very close to the oil industry, the energy industry. So there's not a lot of discussion. Texas was not the best place to get people to come in for a kind of a balanced conversation about climate change at that time. We had a big room, and we ended up having like 30 people out of like 3,000 people at the conference. So disappointing. In terms of attendance, people hadn't heard of the topic, and not that many people came to the panel. So that was kind of disappointing. We did have a pretty good discussion, and I'll talk about some of the things that some of the points that people made. Okay. All right. So we had an introduction to the idea. Like for some of us, we didn't really know this background, and we were learning more and more as time went on. So this. Doug McMartin put together this presentation. The biggest thing here is we do have instances in the past where we have altered the climate, we have altered the temperature temporarily, and from natural phenomena like volcanic eruptions. And so here's an example. In 1991, there was an observable decrease in the average global temperature after that event. And so there are things like that. So the idea was actually inspired by nature rather than being dreamed up by people that were just academics. We're just looking at or people just looking at the chemistry involved. So inspired by volcanic eruptions, some of the things that have already been observed. And some of the roles for aerospace, one is that observation kind of mission, getting up there and sampling so that we can validate chemistry models, which are very important because all the climate models have a lot of uncertainty. If we can dig in and gather more data for the folks doing the modeling of the atmosphere, that's very beneficial. So there's definitely a role for aerospace there. There's a role for satellite observations, but also collection of the molecules, some of which may not be able to be accurately determined from spacecraft looking down into the atmosphere. So a lot of things there. And then if you are doing any experiments in terms of doing something with the chemistry up there, you need to be able to observe it before and after, figure out if what you're doing is actually having the effect and the consequence that you intend. So observation is a big part of the role for aerospace. Deployment. So there were ideas at that time that if you are up in the stratosphere, which varies from 10 to 25 kilometers up, depending on kind of where you are, the equator versus the poles. I have a little diagram over here on the right. There'd been an initial study saying, maybe if we can get SO2, which is a sulfur aerosol, up into the stratosphere, that may have the same kind of effect that the volcanic eruptions had. So some discussions of that. So is that something that aerospace could do? And I think maybe that seemed like a pretty interesting idea. That was what was discussed. Looked at, what kind of airplanes can get up that high. We'll talk more about that. But in terms of airplanes that get up high and carry significant payloads, those two things are sort of opposed to each other. We have airplanes that will go that high, but they have very little payload. We have airplanes that carry big payloads, but they won't go that high. So we don't quite have the systems that we need. Very interesting problem for someone doing aircraft design. So that was one reason I was especially interested. 60,000 feet. I mean, 35 on the pole at the poles, but you want to be higher than that. And the higher you can put it up there, the longer it will take to come down. So yeah, higher is better, but clearly, right, there are trade-offs in taking an airplane up to very high altitude. So that comes into play. And so people were actually doing some modeling at that time, and you kind of see on the right, we'll go into this in more detail. They were showing basically if we do nothing, the Earth is going to heat up. If we only inject at the equator, you're going to get some red zones and some blue zones where it works and where it doesn't work as much. But if you're careful in the way you deploy the injection of the aerosol particles, you can get something that's fairly uniform and might be quite practical, right? So these are the kinds of discussions that were going on there. Everybody acknowledged a lot of uncertainty. You can't just do this. You need to slowly experiment. You got to build up your models. You have to do. There was discussion of space-based systems, right? Doing something in space. This L1 point being the favorite spot. And see, I'm not an expert on orbital mechanics, right? But the L1 point is where the gravity of the sun and the Earth are in balance. It's much closer to the Earth than the sun because the lower mass of the Earth. So that's a place where if you could deploy something, you have to station keep possibly to keep it in the vicinity. You might move away a little bit, but it's in the right place to block some of the incoming solar radiation. So people had started looking at that. Nobody really liked the idea very much at that time. They're saying, if we launch Delta rockets, we need 270 launches a day for 50 years. And, whether these numbers are all right, I'm not sure. But that was the kinds of things people were saying. They said it'd be cheaper to just, convert our energy system to renewables. And so they didn't, nobody liked it at all. And so they actually called it entertaining but silly. All right. But they said without some new ideas. Okay, so that's kind of where it was left. So I was a little bit discouraged there wasn't a better space-based solution maybe that we could be looking at. But what's changed since 2017? Well, it's hard to say that the Earth is not getting warmer. Reports are coming out. The other thing that's coming out is that the price of rising temperatures will not be equally felt, right? The developing world is generally a lot of population closer to the equator. They're actually going to potentially have a much worse time accommodating and adjusting to higher temperatures. And so there's some fairness between different countries that comes into play as well as poorer countries having a harder time mitigating it, right? You can't just hide under air conditioning if you can't afford and you don't have the energy structure to do things like that. So those kinds of things have been coming up. This is from I grabbed something from June of 2023. You can virtually find something almost every day, right, in the news about these. And the idea of geoengineering is now being taken much more seriously in multiple studies. These are from the National Research Council, talking about climate intervention, carbon dioxide removal and sequestration, reflecting sunlight to cool the Earth. So these are high quality organizations that have some scientific standing and some policy and government standing that have been starting to look at this. I'm not going to go through them all in detail, right? Here's another one from the National Academies. A couple of them, reflecting sunlight, recommendations for solar geoengineering research and research governance, right? These are the kinds of reports that are coming out on a pretty regular basis. Here's one on ocean-based carbon dioxide removal and sequestration. Someone pointed this out to me. I actually hadn't seen it. There's actually a White House report that came out in June of this year talking about what should we do for planning for solar radiation modification. Right? So serious activities have been started, at least in the terms of planning and saying what research should be done. I'm not sure. I don't see any, people may know more than I do. I don't see any agency really working it very hard at the moment. Yeah. I think they're all starting to consider it. I don't see the money coming yet, and the research programs actually being kicked off. Oh, I don't know. That may be a problem in itself, right? For me, my aerospace spin on all this, I think NASA should be leading this. Now, certainly that's only part of it. It's a multi-government agency thing. They've come together to, the government has a climate action plan, and the government agencies are lined up to do that. But that action plan does not include the kinds of active solar radiation measures that we're talking about. They include how they change the energy and reduce the emissions. So they're coordinated across on that. Someone may be able to come up with something more specific, but I don't think that's happening much yet. But I think we're much closer. Certainly, if the White House is talking about it and Congress is mandating this be investigated, we're getting close to having some kind of coherent approach to this. And some more things. Okay. And then you're starting to see some things. There are people that are starting to think about the problem of making those measurements up at very high altitude and for long periods of time. Here's an example of a little program. Like I said, I consulted for this Electra.aero company a little bit. They have a small contract. They're trying to get a UAV to fly into the solar-powered UAV to fly into the stratosphere. There are other people looking at this as well. Various problems in getting such a lightweight aircraft all the way up and keeping it up and many things like that. But the idea is to make observations for long periods of time up in the stratosphere, which is one of the things that we identified that we should be doing. And then you want to get a little bit crazy here. I ran into these guys, makesunsets.com. If you give them money, they will buy aerosol, put it in a container and send it up in a balloon. They'll send it up to the altitude into the stratosphere. They then pop the balloon, they blow the aerosol out, and they will do that. It's more of a statement to make than something that's really effective, right? Because it's such small amounts. Yeah. So, well, they're working at biodegradable balloon materials and all these things, but right. So people are starting to think about it. I mean, I talked to these guys, and they actually get death threats from people saying, what you're doing is you're allowing people to pollute because now you're telling them if they buy this service, they can offset their emissions. And yeah, they actually have some concerns about their own safety, which is kind of disturbing.
Don't make some sense because it turns the sun more red. Right?
I don't know. Okay, so anyway, there are people looking at that. I haven't given them any money, but if you want to, they will gladly take your money. So the question is there a better way of getting the aerosols into the stratosphere? Could be. I think the canister is filling it.
Yeah.
They may be putting the aerosol in with the balloon. I'm not inside the balloon. I'm sure. Okay. All right. I put this slide up again on the space-based things, right? Because before 2017, it's like this is silly. But what about, you have any other ideas? And so then I could think, well, what's changed since then? Well, maybe we use in situ materials instead of trying to launch everything in a Delta rocket. You essentially get a fleet of robotic spacecraft that do this kind of thing. Maybe they just do it. Okay, good. Yeah. Right. Yeah, because launching and their calculations use a Delta 4. That's a lot. Maybe integrated with space solar power in some way. Should this be reconsidered? I think it should be reconsidered by people that, have the knowledge in order to put together the study to look at this. And it should not be dismissed out of hand, which is kind of, happened as recently as just a couple of years ago. It's basically dismissed out of hand and not investigated. But yeah, so far, 2015 study, they didn't like the idea of using anything in space. 2021 report reflecting sunlight, they ruled it out from basically at the beginning of the study without analysis. Basically, previous studies have shown this is a bad idea, so they didn't look at it. I'm not happy with that. I think it should be looked at by people that have maybe some more detailed knowledge. So. And yeah, if you look it up, it's got its own Wikipedia page. It's not necessarily really nicely up to date, but the idea of putting some kind of sun shield at the Lagrange point number 1 is out there. Okay, so it's starting to get to, but not a lot. Here's an article from July of this year talking about, okay, we're starting to put resources in terms of calculations into doing more and more work on atmospheric modeling and things like that. So increased computer power, maybe, AI application. Everyone's doing AI now, right? So AI is the buzzword of the year so far. Applying those techniques, maybe new techniques, maybe more activity going on. So that's something that's interesting. I was reading my Economist magazine again, and the other day, this popped up, talked about, turning up the heat. The heat waves are evidence climate change is speeding up. Is it? And they talked about, probably all these different things, records are being broken. And then they sort of finished the article by saying, we might need, you can see, sunscreen for the planet. And they have mentioned solar geoengineering a few times. And, so it's in the relatively mainstream news, and this is kind of, The Economist is a slightly left-leaning, but it's economics, right? So these are relatively conservative people. They have a little bit of a bent toward the liberal side. They're a little more open to some ideas and things like this, but they think by looking at it, solar geoengineering may be the only way to provide cooling in the near term, because it's going to take longer, in their opinion, to reduce the emissions and have that feed through and reduce the temperature. Okay, so in this workshop that was held, this is really what inspired me to do this talk. More activity, more material, more people talking about it. In June of this year, the National Academy sponsored this climate intervention in Earth Sciences framework. So they talked about not just airplanes and spacecraft, but they talked about the social and the policy implications that might be involved. I guess these are what they discuss: how to design research programs, how to assess the risk, navigating societal and physical system implications, unintended consequences, natural social system interactions, right? Government research, how that gets planned. What else? Earth systems predictive capability, current observations and monitoring, and scalability and readiness of different techniques. So that was what their charter was to discuss. All right, and okay, and so I grabbed some things from there. Ken Calderia from Carnegie had some good slides, and so I've used some of those. These slides, there's quite a few, and they look similar to this, right? The idea of what can we do, and we're going to talk about reflecting aerosols, maybe in space mirrors or some other space thing. But as you can see, other people, CO2 capture, sequestration, lower altitude cloud seeding, iron fertilization of the water, all these other things. Afforestation is planting more forests and sequestering some of the carbon in a biochar is one of the things they can do rather than having them burn up in a forest fire. Those kinds of things are being looked at as well, right? So I'm going to talk about the aerospace kind of focused things, but there are other things that people are talking about. So Ken is from Stanford University, and model results indicate that solar geoengineering could offset most climate change. So people coming out and saying things like that. And operational solar radiation management, I'll define it in a minute, is the only known approach that could be deliberately implemented to cool the Earth within a few years. I think they might be a little optimistic given how long it would take us to build a new airplane. We could probably go pretty fast, but you know, a few years is probably pretty optimistic. It is extremely optimistic if we don't get ready to do it. If we just go from where we are today, how long would it take us to build something that would do what we needed to do? Probably a long time. If we design it, we test it, we get ready to do it, and all we have to do is build them, then we can get much closer. So that's kind of maybe where I'm at, is to let's see if we can design the system. We don't have to deploy it yet, but we need to get to, we can save a lot of time if we design it, test it, get it ready to go in case we need it. And he started this, talking a little bit more about how the solar radiation modification would work. The stratospheric aerosol injection is at the highest level. You'll hear other things going on: marine cloud brightening and cirrus cloud thinning all affect, right, the flow of essentially power and energy going up and down through the atmosphere. And so the terminology is confusing. This is, maybe you may hear these other terms. I'll be focusing on SAI, the stratospheric aerosol injection. I have a harder time actually explaining the other two, but.
Would also be by.
Well, I think maybe, but I think the marine clouds they're mainly thinking of using ships to influence their. Would be, yeah. And conventional aircraft can work at the lower altitudes, so you don't actually have to develop a new technology. Yeah, people have been seeding clouds to alter rainfall for forever, really. So there are things that. Okay. And the discussion, here's a little bit of data on what happened after the Mount Pinatubo eruption in 1991. There was an observable 0.4 of a degree Celsius reduction in the worldwide average temperature after that. And it took several years for it to recover back to the level before the event. And, it's not a completely controlled experiment. You can always argue about things, right? Because other things may have been going on, but it's, to a scientific, reasonable probability that, that you can predict these kinds of events will have these kind of effects. And they continue to do their environmental models, calculating, right, if you doubled the CO2 from the beginning of the industrial age, the temperature rise predicted by these models was at 3.2 degrees Kelvin. And by using solar geoengineering, you actually could potentially control that to something very near zero. And you could have it also be fairly moderated around and fairly evenly applied around the Earth if you did it right. Some places might get a little cooler, some places a little hotter, but if you keep it within a degree up and down, then maybe that's a really good solution, maybe. It also affects other things, all of that, right? It affects the rainfall. This talks about precipitation. And so, even in the nice model we had with pretty even temperatures, there's some extremes in precipitation that might affect some people, and that's a concern, right? If you have big floods in one part and droughts in another, but you've controlled the temperature, you may have messed up, one country's agriculture, for example. So, and these are calculations. How good the calculations are as good as what the models and the data used to calibrate. Back to the idea of when we get better data, we can calibrate these things better. Okay, a little bit about how you might apply the solar radiation modification. You could imagine here's, right, this is time. As things are warming up, you could say, okay, we're only going to let it warm up to a certain level, and then we're going to use this solar radiation modification, whatever it happens to be. And you have scenario A. That seems pretty rational. but you have to be ready for a big deployment all at once in order to bend this curve all the way over. If you're not doing that, all you're, like scenario B, you're just kind of shaving off, you're ramping it up, but you never really bend it all the way over. You just kind of shave off some misery, right, in this region. What else? Oh, the red curve is bending over because you're assuming that we're also reducing our emissions. First scenario basically said, forget it, we're just going to use solar radiation modification to solve our problem. The second one assumes we're buying a little bit of time, or we're saving some, like I said, saving some misery until we can reduce the CO2 emissions and bring it back down again. Scenario C basically says, okay, we let it, we're going to implement all these measures to reduce our emissions. It's going to take a while for it to bend over. We can take the top off of this by using the solar radiation modification. And scenario D is a variant of that where it has to get bad first before we react. So scenario D basically says, we decide, takes us a while to decide, it takes us a while to deploy. Once we decide there's a problem, so that's right. I think scenario D seems most likely to me. Okay, but I mean, that's what the chart is. I think it takes a decade to deploy it, and the effect is much faster. The flip side of that is if you stop doing it, the temperature is going to pop back up again very, very quickly, right? Like the volcanic eruption, that time constant for the volcanic eruption was what, maybe 4 years, the whole cycle, 4 or 5 years. Yeah, so easily if you did this, it'd take a couple of years, and then if you stop doing it, a couple of years, the temperature would shoot back up. So that has some risk in it too, as a society, right? Okay. So I don't know, you think about these things, and lots of people are thinking about it. Okay, another study where they're trying to say, what's the best way to intervene to affect the climate? And here's a plot that has affordability on the x-axis, so higher is better in this case, and effectiveness, how much can it bring the temperature down, on the y-axis. And this is just a reference dot. It isn't really any data here. So they're saying that stratospheric aerosols are the most effective way to reduce the temperature, and it's the second most affordable method of doing it. Planting trees is the most cost-effective, affordable way of doing it, but the effectiveness is less than half of the effect of stratospheric aerosols. How exactly they define it is probably delta temperature and with many uncertainties. But I mean, you see other things down here, like, I don't know what, well, they have space reflectors up here, right? So they're saying that could be very effective, but it's going to be much less affordable, was the way the study came out. Carbon capture and sequestration, one of the different technologies. That is, ground-based kind of technology is kind of in the middle. Some of the other cloud things. So you can kind of see what stands out from here for me, right, as well. I'm looking, this is, stratospheric aerosols and space reflectors. Those are the things of interest here. So if we can increase the affordability of the space option, then we're still working things up in the kind of the upper right corner. So those are good things. And everybody likes more trees, so that's a good thing to do. Okay, so the study kind of pointing to, stratospheric aerosols. Wake Smith, I've talked to him quite a few times. He's a lecturer in this topic for quite a while. He brings up the Pandora's toolbox, the hopes and hazards of climate interventions. This is what he presented at that particular workshop. And if you're familiar with Pandora's box, it's essentially it's mythology, basically saying that chaos will be unleashed on the world if a curious person opens this box. And that's the fear, right? Is that if we start doing solar intervention of different ways, what have we opened in terms of a Pandora's box of chaos and uncertainty? And this plot, similar, much more simple than the last one, and then using new acronyms. Part of teaching these subjects is just, hey, these are the stupid acronyms that are used. Get familiar with them, because but people would just rattle them off and they won't ever stop to explain it. So SAI, stratospheric aerosol ejection, MCB, maritime cloud brightening, CCT, cirrus cloud thinning. Right? He's a fan of doing the stratospheric aerosol injection. Yeah, I saw his presentation. I could not reproduce a couple of these acronyms. And if you Google CCT, you'll find all kinds of other things. It's actually very hard to actually figure out what acronym stands for. Surprisingly difficult.
Yeah, other more clouds, how they would do it.
More clouds. I'm not quite sure if there are other elements to it than that. The tops of the clouds, can be very reflective, and so that can be a good thing. So I don't know. We have to look at that.
Sulfur dioxide in the atmosphere would be on the island. Sulfur dioxide ends up coming down.
Yeah. Right. So those, having good models, we don't have enough data to trust them in detail yet. It's kind of a big risk. Okay, so talked about, you could call this artificial volcanoes. You only need to deflect 1 to 2% of the incoming sunlight. That would drop the temperature down. You'd have to do it continuously. We know the sulfates will work. We don't know if other things will work because we don't have any data, right? We have data of what the sulfates, aerosols do because we have the volcano data kind of thing, but we don't have anything. There may be some more benign chemicals that can be released that would have fewer side effects. There's a global circulation of these things, but how do we ensure that it's kind of evenly spaced? So anyway, that's that. And then I throw Saturday Night Live into my presentations sometimes, but in this case, Wake Smith did What Could Possibly Go Wrong? There could be bad physical consequences. We could get it wrong. The stratosphere could heat up because of this, and does that have an effect that a negative effect that we don't know of at the moment? Eventually, the sulfates are going to come down, and the possibility of acid rain, and they would tend to go toward the poles based on the way things circulate, and it could actually damage the ozone recovery that we sort of are. Fingers crossed, we're enjoying a recovery of the ozone layer and repair of the ozone layer currently. That'd be a good reason to figure out some other chemical that will also have a similar effect without affecting the ozone or acid rain. It's a risky experiment in the only atmosphere that we have, so that's kind of a concern. Political conflict. Some countries might be happy to be warmer. They're now increasing their crop yields on the northern parts of their country. Maybe they don't really want us to control the climate, which is really stabilizing the climate rather than having the climate, go back to something. And what else? Yeah. Who gets to decide, right? Does the US get to decide because we're the most, advanced technically and we're the only ones that have an airplane that will do it? Is it a United Nations organized activity? What happens? And then equity and justice are we hurting some parts of the world? Just an emphasis. The thing is, the heat waves are affecting the people. And there are many people that live in this zone, These are the people that will be most adversely affected as the temperatures rise. We have a couple hand raised. Ken, do we have a question from the audience? Well, I mean, oh yeah, I'm trying to think. Okay, historically, the sulfur was coming from burning coal in power plants, and then it would circulate and then fall in lakes, and you acidify the lakes and you kill the fish, you destroy the ecosystem. And there were, essentially areas that were large distances away, but downstream in the way of the circulation of the emissions from coal plants that were creating dead zones, dead lakes, things like that. And they put scrubbers and restrictions, and they reduce the amount of coal that's being burned for power, and they clean those areas up significantly. So that's kind of the history of that. We would have to, that is a possible bad side effect of doing some of this stuff. So we'd have to look at that. Okay, there's a question from General Charlie, what? Bono. If you have a question, you can ask it now. Yeah. Well, we'll come back. We'll come back to it. Okay. A little, to zoom in a little bit on terminology, where's the stratosphere? Where's the troposphere? Turns out, when we do our aircraft design, we have a standard atmosphere. It actually varies, right, between whether you're at, this is the equator in the middle, and the poles are left and right. So we say we want to get into the stratosphere because the particles will circulate in the stratosphere for a long time before they come down. So depending on where you're doing it, you may need a higher or lower altitude. And the next slide shows some of the complicated circulation and mixing that goes on between those different layers. Here's kind of, right, the blue line is the troposphere, stratosphere boundary. And so you can see there's a lot of complicated mixing that goes on. And so, this is one reason why the climate modeling is so hard, is that, it's not a two-dimensional problem. It's a very complicated three-dimensional mixing problem. All right.
Cell, right?
It looks like it, yeah.
Between the pole and the equator, towards the equator.
Right, and it also shows that if you're emitting anywhere here, it eventually will end up in the poles, more likely. The other, yeah.
And then there's another possible flow upward at the high latitude. If you look at the downflow and
so certainly plenty of challenges, right, for the climate modeling, atmospheric modeling folks. Generally, the conventional aircraft don't fly high enough, or they don't have enough payload to put a significant amount of the material up. Commercial aircraft, are not going to fly much above 40,000 feet, which is just a little bit here, a little bit above like 12 kilometers. Fighter planes can go up high, but they can't stay very long, and they don't carry a lot of payload. I think some of the UAVs can fly at 60,000 feet, but they carry a sensor pack and they don't carry significant payload. So we don't really have the right airplane to do the job. Although we have essentially we have air vehicles that could test the concepts, but not necessarily do the job. There have been people looking at other possibilities, the balloons, we mentioned the balloons, conventional rockets, guns to shoot things up, high altitude dirigibles and blimps. There have been studies that people basically have said all of these things are bad, none of these will work. That doesn't mean that's true, that just means I would agree. So, none of these things should be considered a perfect decision already made and obvious. So, right, so things need to be looked at. This was what Wake Smith was involved in the study. He liked this airplane. I'll talk more about this in a little bit. It looks like a B-47. It has somewhat bigger wing. It can fly up to higher altitude than that plane was designed to. So anyway, there's some design considerations for an airplane that might look something like this that could carry a more substantial payload, right? U-2s can go very high, but they only carry sensors. This would be something that would go up very high, but also have a, 30,000 pound payload. Yeah, I mean, he's concerned that we won't notice that we've got a point, we'll determine too late that we need to do this. That's kind of scenario D that we looked at where, oh my God, it's too hot. We're suffering a lot. It's going to take us now 20 years to deploy the system. So I think he'd like to, be prepared to do it quicker than that. He does say it would be a rapid impact to the climate once we got it ramped up. So his take on it was it wouldn't take very long to have any impact, but getting started is where the time would be. Yeah.
Disperse the stuff, you disperse it all in one location and it just diffuses throughout the atmosphere, or do you have to disperse it within like every 100 miles, or how dispersal? What are we talking about?
You have to distribute the dispersal somewhat, and the rest will kind of mix together. The reason you disperse it, I think, is to try to make the effect more uniform. So you help that out by having multiple sites where you would be dispensing it from. I think that's the main thing. Yeah, it's going to mix some, but what you have to do is make it so it's fairly even. Okay, this is a little bit of a weird way of saying it, but what he's saying is this is not the solution to CO2 and climate change. All the measures that we're planning on taking to try to knock down our CO2, clean up our act, reduce the impact of climate change, that's plan A, right? That's what we should be doing. This is something to add to that, not to do instead of. And he does think, though, that this might help save those regions of the world that are really going to be really suffering from the increased temperature. So if anything, you turn this around a little bit, this would help areas of the world that, they're not going to be able to electrify and give everybody air conditioning and change their entire economy and their entire culture around. This would maybe a way to save, some of those folks. Okay. Here's the paper that has the airplane in it. I talked quite a bit to some of these guys. So I'm a little bit biased. I've been trying to get them the ability to talk to people within NASA and the AIAA and things for a while. And so their pitch is out there, and they've done that a little bit more on their study. They went back and grabbed different studies that people have done looking at the cost per ton to put these aerosols up in the atmosphere.
This is Charlie Vono. Could I say something quickly?
Oh, sure. Go ahead, Charlie.
I had made a comment earlier where I thought that if you're dealing with a complex system like this, like you mentioned earlier, you weren't terribly afraid of addressing complex systems because you knew you had to do that. And I made the remark that on the comments that, the federal government is not known for being able to nimbly address complex systems and then reversing course when they find the thing they did had an unintended consequence. But what you're describing here is exactly what FDR did before World War II when he developed the B-17.
He's preparing the technology for a possible need in the future.
Exactly.
Yeah, it's fair. Okay. All right, so thank you for that. This chart is an analysis that was done to compare the cost of doing this, of taking these sulfate, or they also mentioned calcite particles, some kind of aerosol up into the atmosphere. What's the cost per ton? And then, so that's the $1,000 per ton in this column. And the far right column is normalized to their airplane, which is they call it the sail. All right, and so you can kind of see this is how they assessed, like balloons would be 28 times more expensive than using this airplane. A gun would be 14 times more expensive. Using NASA high altitude aircraft with lower payloads would be 30 to 35. Global Hawk, 50 times more expensive. SpaceX Falcon rocket, 50 times more expensive. 16-inch gun, 100 times. A Virgin Orbit rocket, I don't know. So whether the numbers are correct, right? But this was used as the idea that if we compare these costs, this aircraft might be the lowest cost way of doing it. And so hence they did their study on the aircraft, right? So that's kind of a challenge to the other modes of deployment, right? Are these numbers accurate? Can you produce numbers that look better than this?
Basic question. I don't, my understanding was it was a gaseous sulfur dioxide that was what was the active uh, ingredient that was dispersed by Mount Pinatubo. That was sulfur dioxide gas, rather than an aerosol or particulates. There were particulates also, but am I right or wrong?
I don't think I know exactly, but based on the context of everything I've seen, it's an aerosol that is, they say, is having an effect. Yeah.
But, you know, if it's sulfur dioxide gas, then one could burn sulfur as opposed to carrying all the oxygen.
Yeah, I think that's, yeah. I think exactly how you deploy it could be, I mean, a tank of sulfuric acid might be carried, and then you have to run it through a process to create the aerosol particles. Yeah, I don't know, something like that. So that's another piece, right? Is the system that would actually do the dispensing versus the aircraft itself. Okay. And yeah, they're intending missions where, you know, essentially you're based somewhere and you fly up and you go and you just fly for about 200 miles dispensing it, 65,000 feet, and then you come back, right? And so that would be every, you know, I don't know how long that takes. You might take several of those flights a day, all, you know, different places around the world, which I'll show you what they were saying. And the other requirement for the airplane is to be able to move the airplane from base to base. And so that would be a ferry or deployment mission. So that would be another requirement for the airplane. Okay. And this was, you know, in some of the thinking, these are the number of bases that you might need. So this is like a dozen bases scattered around the world, and they would be able to fly out from there only a few hundred miles, and that would be enough to give an even coverage. So thinking so far on this. And the airplane, the characteristics of the airplane, if you're interested in that. The takeoff gross weight would be 130,000 pounds, which is kind of a small airliner size, actually. Not that crazy. What else? 70,000 foot altitude, though. That's kind of different, right? That's the main difference. The speed is not that important because you're just dispensing, but it turns out you can't go, it's a very interesting aircraft design problem of flying very high altitude. One way of doing that is to fly fast in order to get enough dynamic pressure for the airplane to work. You can go with a bigger wing and fly slower. So there's all kinds of really neat trade-offs for the aircraft design folks. Okay. The payload, right? Doesn't take up necessarily that much space, and it's not really that heavy. You know, a commercial airliner or a cargo plane carries a much larger payload. This one, in their study, was designed, I think, around a 30,000 pound payload. Turns out a very interesting surprise. I put in to the AIAA aircraft design technical committee the idea of doing an airplane like this for the student design competition. And they said, no, we have all of our design competitions already figured out for the coming school year. Maybe do it the following year. And then a couple of days ago, they came back to me and said, you know, the one we were going to do for undergraduate students, individual students, that one that wasn't ready. So we're going to use yours instead. So actually, the AIAA rolled out a couple of days ago that the 2024 undergraduate individual student aircraft design competition is going to use these requirements for their airplane. And so that's going to be very exciting. And we'll see what kind of ideas come out, or if they all end up looking like the airplane that I just showed you. Okay, so I think I have, what else do I have? Oh, I have a couple things. So to kind of talk, we'll open it up to Q&A. We'll have a discussion. We may go around the room with questions. We may, you know, open it up, but let me lead us off with a couple of things. My summary is The stratospheric aerosol injection has the potential to lower global average temperature, but there is uncertainty and risk. Seems to me we need to work on this now in case we need to do it in the future, which involves gathering additional data to improve and validate atmospheric chemistry models, do experiments both in the lab and limited, well-monitored experiments in the atmosphere, develop designs for potential aircraft and the dispensing systems that they might need in order to do the job. We should revisit some of the space-based approaches because things have changed. Maybe we need to update those. And then if there's good interest, right, we can assemble a panel either locally here, or we can do a panel at one of the AIAA conferences or something, and get some of the experts who I'm grabbing, right, their charts and things, trying to answer questions about their material, get some of those folks in, and they can, you know, have a more detailed and in-depth discussion. And one of the things already that's happened is someone contacted me and they said, have you seen this? Another idea someone had was a fleet of solar powered stratospheric UAVs, and they called the concept flying leaves. So essentially you make mass produced solar powered UAVs that fly around, loiter in the stratosphere, reflecting, and they have large areas and they reflect up. So I had not heard that before. That was brought up to me. Yes, so I added it on here as one of the things that we could discuss. And I don't know if the person who's at Ravi who made that suggestion is online here today. He could talk about that for a moment if he's online. Okay, and then I think that's all. This is the article from that I was given on that. Oh yeah, it is. That's in, yeah. That's not even my mistake. That was I copied that. Anyway, right. So more people are starting to research this. I don't know, you know. So I was happy to see that people are looking at things that I didn't know about. So I think that's it. Okay, there's the RFP. All right. So let's just go back to discussion. So I'll wrap up. So questions, discussion. Okay, we have a question here in the audience.
Over the next. They're obviously not going to practice. They're going to be very low level. Is there any way to leverage that? Because we're going to be doing that anyway.
Yeah. So the question is, or the comment is that eVTOLs and drones are being deployed in greater numbers now. They don't, you know, there aren't that many plans to go to the stratosphere. Maybe there's starting to be a few plans to take some of those drones up there, but generally not. Are they just going to make the situation worse by, you know, having emissions at lower altitudes or whatever, or are they can they be leveraged for this? And I mean, I'd like to see someone actually do, you know, a high altitude solar powered UAV that can take off and reliably get up to the altitude and loiter. And so people are starting to try to do that. So the question is, can you do something at the, you know, 1,000 feet or something, right? Rather than having to go. I don't think you can do, you know, the stratospheric, you know, aerosol. No, we can't do anything on that. But some of the other things that we talked about with the clouds, maybe there are some things.
I saw something with the drone show instead of fireworks, like Tavo, and they were using drones and, you know, formation flying and fantastic. And so that technology is there. You could have a fleet of solar powered airplanes that flies over a city and just shape, okay? And then maybe they even make power and send it somewhere else. But if you were to be able to put up a big shade over Phoenix, which is, you know, how many days over 110 degrees in a row, you know, I mean, or Delhi, India, or, you know, these places where people are using air conditioning, using extra power when it's so super hot. If there's a way that you can create a spot of shade that pulls things off, then that would be a, very simple thing to do. I mean,
So-
and then maybe you do something with the power too, but
So yeah, so the comment is that you could use fleets of low altitude UAVs for temporary sunshades.
Yeah.
I'd say you just have to do all of the calculations to evaluate that, right?
Yeah.
So is the electricity that you're using to charge those going to make it worse rather than better?
This is Charlie Bono. Is there space for me to say something?
Go ahead, Charlie.
Just speaking as a former Air Force tanker pilot, I'd say that your design there for a dispersal aircraft at 80,000 feet, the pilots are probably redundant. You probably want to computerize the whole thing.
I think that's valid. Yeah. I mean, I could see you start out with pilots. You may end up with like pilots in pressure suits. You may end up those kinds of things. Eventually, you could get rid of them, right? Should be able to do that. Automate the whole thing.
Yeah, I'm thinking especially of things like once you get to that altitude, the pilot's ability to control the aircraft is much less than a computer's ability, right? Nowadays, we've got the technology.
I think that's a good comment.
They want to use some hybrid, blimp aircraft. I don't even know what to call them, but various, inflatable aircraft that are extremely light and have a lighter than air gas that keeps it buoyant at the same time. I'm in this sunshine thing too.
I mean, okay. So the question is, what about blimps and other hybrid blimps and hybrid airships, things like that? Inflatable aircraft. I mean, one approach would be to essentially pay people per, ton of aerosol delivered, and then let innovation figure out whether that would be launched from a gun, an airplane to deploy it, a balloon, a blimp. That would be one approach, right? That could take that some people would probably like that kind of approach. Probably, yeah. So I think there are possibilities. I mean, once you have vehicles that can get up there on a regular basis, then you can start thinking about what their payloads are and what they can do.
This is Martin McLaughlin. I have some comments, if now's a good time.
I think so, Martin. Go ahead.
Okay. Marty, you and I have a similar background. I had 39 years at Northrop Grumman, retired 2 years ago. Did the low observable aircraft and fighters, but I also had 17 years of space transportation systems that I worked on. And by the way, thanks for doing this. And I certainly agree that we don't want to do this in a panic. We need to have some proper analysis, simulation, and building block risk reduction like we're used to doing in aerospace, and not run off half-cocked on something, right? It would be terrible if some country got in a panic and unilaterally decided to cede the atmosphere, without international consensus and agreement.
That is a significant concern that you hear voiced.
Yeah. I've got two concepts that I'll send you an email summary on that are LEO-based reflectors. And I came up with the same square footage of, or square meters of shield that's required to reduce. Assume I was using to get a 1% reduction in the solar flux. And when you count the diurnal cycle reduction and other aspects of that, it's not quite 4 times like one study that said there, but it's quite a bit more. But with a deployable system that you can the first of the two concepts is a deployable framework that it's telescoping spars and posts with that stretch a membrane between them. It takes a, and I got it telescopic enough that it'll fit in national security space launch category 3 fairing, which is the big fairing that can fly on it. An ULA or vehicles or Falcon 9 or Falcon Heavy. And with that, it'd take about a little over 1,000 of the things to get a 1% reduction. And the other concept is actually neater. It's an on-orbit blow molded sphere. Take a polymer and blow mold a thin sphere with that, and you just sort of let those up there, and probably in like a high LEO or a mid-Earth orbit. And it would take a lot fewer launches because you could bring up enough polymer that you could blow mold 4 or 5 or 6 of those spheres at a time. And but any of them are, a fraction of the cost of the reducing the carbon content, small fraction. I agree that we need to, it's, you brought up that you even get death threats over that. That's crazy, but if they're, and we should do everything we can to reduce the carbon footprint, but it's going to take decades and decades and trillions of dollars to do that. I mean, what would it take to convert a carbon economy to hydrogen? I can't even imagine. Or on-orbit reflectors would be a fraction of that, a small fraction. Now there are, I've already talked to some astronomers, and they're, oh my God, you're going to ruin our astronomy, and you got to worry about that. But if it's blocking out 1% of the sky, well, let's see, it's more than that because of the diurnal cycle. So maybe it's 3% of the sky. Maybe they'll get all mad, but it beats flying.
We had another question about that as well. Starlink, right, interfering with astronomy, but it should only be when you're looking at the sun. So the solar astronomers should be really unhappy, but the rest of them might not be that upset.
Well, these if you were in that's the advantage of being in a solar orbit like Earth, Sun, Lagrange point. Then you're just pointing at the sun. If it's a LEO orbit where you go, and I'm doing that because it's so much cheaper to get there, right?
Oh, okay. All right.
Then they're flying around all over the place. You got 1,000 of these things up there. They're not that big, but there's 1,000 of them up there blocking the sky periodically, right? But I don't know, that would have to be one of the things considered, and there have to be a debate about it. It might matter, maybe you could put them in inclinations that the orbit inclinations that the astronomers don't care about that much. I don't know. But worldwide astronomy is not as important as worldwide survival. So it depends on, again, back in the beginning of your presentation, whether you believe we have a problem or not.
Well, yes. Are you willing to give one thing up to get this? Yeah.
And there's, you can mitigate it somewhat with what orbits you choose. And then the other is the astronomers are getting more and more good, in space telescopes. So they ought to be happy about that.
Yeah, I mean, give them space telescopes, right? They can give them a big budget for space telescopes, and then they
and save the Earth. That would kind of be a good deal, right?
Yeah, Charlie Bono here. Make sure we get those asteroid detector satellites out there first.
Yeah, we need some of those at about a Venus orbit so that they can look out and find anything more dangerous. But yeah, and then they, the astronomers all want the far side of the moon to be kept pristine for radio astronomy, and don't put any satellites in orbit around the moon that emit any radio frequencies, you're going to ruin our astronomy. So we'll see. But anyway, I'm glad you did this. It's too bad your meeting in Texas didn't go well. I'd be glad to participate in some future one. But thanks for doing this today on Saturday.
Yeah, I think the meeting in Texas would probably go better today in 2017.
I happen to live in Texas.
Do you? Oh, great.
Lockheed asked for me on loan on the, I was the airframe director on the F-35 for them. Still a Northrop employee, but so I moved the family here for that. Been stuck here ever since.
We have a question from James Sloan. James, do you want to ask your question? Okay, let's go around the room here. Any comments? Any comments?
Okay, can you hear me now?
Are you James?
This is James.
Okay.
My question is on absorption of CO2 in the atmosphere. Has anybody been looking at potential dual uses of removing the CO2 and also stationary power storage?
Yeah, I think there's a lot of activity in studying how to economically pull CO2 from CO2 sources like power plants and other industry, as well as pulling it from the atmosphere and turning it into things like, I don't know, sustainable jet fuel and other products. So a lot of activity, yeah, is looking at things like that. I mean, the questions I teach the people in my course is all of the challenges of doing that. You need vast amounts of clean energy to do that, and supplies and materials and water and different things. So there's a lot of challenges.
Well, I was wondering too, is with basically with aircraft, the difficulty of transitioning to, say, a hydrogen aircraft versus remaining with a carbon-based fuel.
Oh yeah, I mean, that's a very active area right now. Okay. Let me bring up one thing that I let slip by. I need to mention it. The space-based solutions that are using, say, rockets to launch things into space, you got to remember the impact of the rocket on the climate. So you do have to include in your calculations, are you making the climate problem worse with all of your launches? And are you giving a bigger benefit? So you have to at least do the math to subtract the benefits from the costs of doing it. And I think we're going around you don't have to answer a question, but a question or a comment from people in the audience. Fuel cells. Okay, question. Estimated 1.1 tons. Here, team. All I'm saying is it's all the above, but hydrogen is right now just in its infancy. And a lot of you probably know Home Energy starts to unveil huge hydrogen production program, $8 billion in woods next month.
around the entire country. So look for that, lots more. But you will tell us what the company, well, the company name is, you won't find much, but we only have, it's Rapid Global Aerospace. And our website is just a skeleton now, it's a placeholder. There'll be a lot more. Coming out. No. My accent. Yeah. And not related to us. One of our concerns has been, is there gonna be enough height?
Are they still doing contrail studies on hydrogen? Not direct question.
Yeah, but there's a lot of ways to make it.
Right.
That's a big contrail.
It's a big topic.
Contrails for hydrogen. To verify and determine when contrails are permanent. There's been studies on sustainable aviation fuel that's driven making that fuel, it has a different probability of contrail.
I don't know, I was gonna say I thought it was a win. And yeah, some things that I hadn't thought about are considered for a while. So yeah, thank you.
Okay, Gary, Gary Lockenauer, go ahead and make your comment.
Okay, can you hear me?
Yes, can hear you.
All right, very good. Well, I know we're doing a lot with improving the emissions of automobiles and airplanes and things like that. But we've got this growing area of commercial use of space. So we've got a lot more companies looking at sending up rockets and putting hotels in orbit eventually, and maybe even vacationing on the moon. And if we have all the rich people on the planet that are taking those kind of vacations and travels in the future, do we have a way of reducing the emissions of rockets, or a way of getting into orbit or getting to the moon without pouring out a bunch of emissions from the rockets?
The emissions from rockets depends on what kind of fuel they're using. If it's a hydrogen LOX, there is no emission. If it's methane LOX that's been derived, produced using clean methods, that's a net zero. So it largely depends on how much there is. And regardless, at least at today's rate, the rocket, as I understand it, the rocket contribution to global warming is a small fraction of what, for instance, airliners do. Over.
Okay. Yeah, and I keep hoping for teleportation to reduce our automobile and airplane travel as well as going to the moon. So maybe someday.
Hey, Jerry, this is Martin. Good to hear your voice.
Yeah, same here.
Yeah, the LOX kerosene rockets are an issue, but it's a fraction of what automotive emissions are. Even if you were launching a Falcon 9 every day. But as he said, LOX hydrogen rocket would have no, assuming you can make the hydrogen and oxygen by clean methods, like somebody said, like with some sort of clean energy. And the methane, you do get a CO2 as one of the byproducts of methane oxygen combustion. So there's some CO2 with that, but it's not as bad as, well, it's more, it stays in the atmosphere longer than the kerosene does. The kerosene would, but it puts a lot of CO2 up too. So I don't really know, you'd have to study that, but I don't think the rocket launches themselves are an issue. 1,000 rocket launches over 4 or 5 years is not going to be much compared to other
One of the concerns
of aviation is right that ground transportation has more options to clean up their CO2 than aviation does. And so
Yeah,
as,
they don't
as
have to
ground,
fly. That's a big problem with.
yeah, well, as ground transportation electrifies or converts to clean hydrogen or whatever they're doing, then that makes the share from aviation get bigger and bigger. And so they're looking at ways to try to, reduce that. I could see a similar argument being made for space launching as well, right? It's small now, but maybe it becomes more and more important as we both increase the number of flights into space for whatever reason, and other modes of transportation are cleaning up their CO2. Something to keep
True
an eye
enough.
on. Yeah.
One thing I'd like to add to this debate is, whatever system we want to come up with, we want something that can be reversible in case we make a mistake or overdo it, or other unintended consequences. And so think about that when we're doing this. Is this something you can reverse if you have to?
Yeah, I mean, the stratospheric aerosol injection seems to be reversible over just a few years in general. I mean, that's also something good for a space-based approach. I don't think it's not as uncertain what the effect will be. It's more of a linear, you're shielding the sun, right? And it's in space, so it's not doing anything to the atmosphere of the Earth.
Yeah, I think it's very determinate.
Yeah, it's easier. There's less risk, even if it may not be. Well, I mean, if it works, it could be less risky and easier to implement.
There's the conjunctions in low Earth orbit with other spacecraft. So the nice thing about these is these shields don't have any fancy sensors or equipment on board. So whatever you do have, you could rad hard and you could put those things up in some high LEO or mid-Earth orbit where nobody else wants to go anyway because of the radiation, and keep them out of the way of everybody else.
Mark, question or comment?
But I think this is an extremely important thing to consider, and it's worth spending time, personal time on. So thank you for doing it. I think that what ought to happen is that there ought to be some real brainstorming. And AIAA as an organization could create a position paper. One could come to a position, find the right technical committee to do it. I don't think to do that, but there's some technical committee or a couple of them that get together and create a position paper and a recommendation. And if you want to make something happen, figure out how to structure it, how to create the organization within the government to do it, whichever organization you ought to do, how to make it happen. And it's one of those things that this really is a threat to humanity. It's a threat to all your grandchildren, and will the number of people on Earth decrease by a factor of 10 because of all the stress that's going to happen? It's a very critical thing to take issue and figure out solutions. Whether this is it or some other, it may not be the sulfur dioxide in the upper atmosphere, some other option, but it's extremely important. I did look up online, and it looks like it's sulfur dioxide, the main ingredient from the stratosphere. So the notion is that if you wanted to get it up there, it's a gas, and you could just take sulfur as an element and burn it in the upper atmosphere and create sulfur dioxide, so you don't have to carry anywhere near the same mass up here. And you might even be able to get energy out. It could be a fuel. You could have a sulfur air batteries give off sulfur dioxide as your exhaust. So they're figuring out some creative solutions.
It's a little bit ironic that, right, we're trying to get sulfur out of jet fuel. And in this case, we might actually be putting sulfur in. So, yeah, to burn it.
You know, and I think there are all sorts of other things. So, you know, another one is that Marty's, one of your slides mentioned it early on, that there's a thought that you could seed the oceans with iron, right, or with iron oxide. And I'm not in the right form, but again, there's some potential that aircraft could burn iron and drop little tiny pellets of microscopic iron oxide in their trail. And I don't know if that becomes a seed for cloud formation or just fertilizes the algae that absorb the CO2. You know, that's the gist of it. But it's a potential for effort. You know, the other kind of small local areas of having a fleet of these plain leaves that takes out, you know, 1% or 10% of the sunlight. So there's an awful lot of different things we can think about. And I think it's appropriate for AIAA to have some subcommittee that studies it and figures out what one would do and then come to some conclusion. That's a logical.
Yeah, I mean, there is a green engineering integration committee in the AIAA, and it's currently basically atrophied. There's no a lot. That's a place where something like this fits perfectly, and it could be their signature issue maybe to be looking at. So that the question is getting some enthusiastic volunteers that are willing to spin it up and do the work, right? Of essentially collaborating around the AIAA to get the panel sessions organized and those kinds of things. So I think we could do it if we wanted to. Yeah, something like that. And maybe, I mean, we're kind of at the end of the time. We're going to stick around in the room here for a while, but is there any suggestions on something that maybe the AIAA LA section could do as a next step? So is this something that, you know, we should have a, you know, like a real meet, you know, like we've had mini conferences before, or we do something like that, or we get some of the local university students to come in, or, you know, how do we do that? Is there other things that we could do locally and Mark, you mentioned, and at the AIAA national level as well. So
how about just getting on the agenda at one of the AIAA meetings, Ascend or one of the others, you know, you get a lot of attendance that way. And you could suggest in that meeting that, hey, maybe a subgroup should be created or something.
Has anybody looked at injecting material into the second stage of launch vehicles as a dispersal mechanism?
Not that I've heard.
The reflector systems are volume driven, and you need the big payload fairing, and it's really not something that's a shared ride with something else.
I'm referring to using injecting sulfur dioxide, so to speak,
into the atmosphere. There's
using the
plenty
rocket
of room
exhaust.
in the forward skirt of a Falcon 9. You could stick all kinds of stuff in there, and then it's way back down. You could disperse it into the atmosphere.
Another possibility would be, and I hesitate to say this because I worry about the unintended consequences, but the folks looking at high altitude supersonic aircraft, which tend to fly at 60,000 feet or more, you know, essentially they could add something to their fuel, so they would maybe have some of these effects that we're looking for here. The downside being is that they're doing potentially damage up there as well. So, but they are looking for ways to mitigate the damage that they might be causing due to their high energy use and their emissions at that altitude. So that's an interesting possible synergy, and I've heard that mentioned by the supersonic and hypersonic people that are interested in flight in the atmosphere.
rocket launch and could rocket in the second phase of the first phase. Could that help disperse this? And what occurred to me was that we used to use methylene nitric acid as one of the reactions for rocket launch. Some hyperdrones, and perhaps you could use sulfuric acid. In some kind of chemistry that would a whole lot of sulfur dioxide and you were going to do a whole lot of runs. I don't know, but I wanted to address that comment from.
The issue with rockets is you're not launching rockets forever. You're only launching rockets from a few places on the planet, right? So that's why I asked earlier about the dispersal question, about how dispersed do you need to get? Because if you do all in one place, then it makes more sense to do localized like a rocket did do. But if you're having to do all over the world, then it makes more sense.
Yeah, so I'm going to respond. The rocket launch is, depending on where you're going, the equatorial launch site is preferred. It looks like in the band temperature in the equatorial region or during the run, the people have 300 days out of the year can't work. So, launch during the equator and then quite a bit of dispersal near the equatorial region. So, and that's where we high altitude. And lower altitude, you can use jetliners that fly over the pole at lower altitude, kind of within the normal range of aircraft operations. Right? So if you wanted to disperse sulfur dioxide over the polar region, then conventional aircraft. But, we tend to care more about the actually have the worst effect of where you the ice and you absorb a lot.
I'm actually taking,
Should be done. Yeah. I think that something should be done to create a mini conference, add it to an existing conference, figure out the local, local and national participation. See how to make things happen, and save the world. That's worth doing.
Yeah, just one last question. On the one, good idea, but the first thing I heard is how much volume and grading has flying mission. Adding something, aircraft would be much more cost effective.
Some of these scenarios would be launching, billions of months, in order to sustain, those kind of ones. That would be extreme, bump in the number of launches. And I will work on aircraft. Aircraft. I don't.
This time frame.
Oh, yeah. I was really curious, what was the orbit for the Leo constellation? Was there a specific orbit? Was it some synchronous somehow? Or what was it? Because Leo could be all sorts of different orbits. Or is it equatorial?
Yeah, what would be the scheme for deploying a low Earth orbit constellation for what reflection of incoming solar radiation? So that's a question to, was that Martin who was suggesting that? I mean, time's up. So anybody can leave at any time now. We're just staying on for a bit longer until we all fade away. But no, okay. I mean, it's a really good discussion, and we energized parts of the discussion that I didn't have enough information on. So I like that part. So anyway, okay. Yeah, feel free to email me. I think I already setting up a couple of meetings to talk with a couple of folks that contacted me already next week. And I'll strategize a little bit about how we want to engage with the AIAA, expanding some content, is what they would call it. So very good. So thank you very much. You guys have been a very interactive audience.
Here we have, thank Dr. Bradley. So we have an appreciation certificate presented to him. Thank you, Dr. Bradley.
Thank you very much.
Thank you. Thank you.
Yeah, thanks for spending your warm Saturday here with us in the summer. I decided not to go with the coat and tie, given that it's a Saturday. And yeah, right. So, creating some controversy when you're in the middle of pandemic.